Welcome dear students to my channel. So let us continue with integration by substitution. Okay, so last time we saw 6 standard integrals, okay, and in this lecture you will make use of the very same 6 standard integrals. Okay, so before we begin with the problems, I want you to pause the video and note down whatever you are seeing in the screen right now. Okay, so let's see the first question of the day. So question 1 falls under type A. Okay, so the type A says that we need to express the quadratic expression, that is ax squared plus bx plus c, in terms of sum or difference of two perfect squares, right? So that means we need to express this as a sum or difference of two perfect squares. So how to do? Let's see. Okay, so here the quadratic expression is this one, right? So let me write the quadratic expression given here. So x squared plus x plus 1 is the given quadratic expression out here, right? Okay, so this is my a squared, right? So basically I'll write this as a plus b whole square. Okay, so this is a square, right? So a square plus, now this is my 2ab. Okay, so we have a as x square, right? So this is my 2a. Now whatever is here, same thing has to be here, because this is a square and this has to be a, right? Now I have to choose b such that when I put that b out here, I'll get only x. So the required number is half, right? Because this 2 and 2 gets cancelled, so only x will be left. Okay, so here we have a square plus 2a, right? B, so b is half, so that's why I need to put b square, that is half square. Is that clear? Okay, now this is extra quantity, right? So I will subtract this part. So minus half square plus 1 is also there, so let me write plus 1. Okay, so let me repeat once again. So I need to write this in the form of a plus b whole square. Okay, so this is my a square, so a square, so basically a is equals to x, right? So after a square comes 2ab. Now 2 is written a is how much? A is x, right? Now I have to choose one b such that I'll get back this number. Okay, so the number has to be half, right? So I put half here. Okay, so now this is my b, so next is plus b square. So if this is my b, so that's why I have written half square. Now this half square is extra, so that's why I have subtracted half square. Plus 1 is coming from this part. Okay, now we know that from here to here is a plus b whole square, right? So that's why this will be written as a, that is x plus b is half, okay, square. Okay, so from here to here we have simplified. Now this is minus half square is 1 by 4 plus 1, right? Okay, so this can be written as x plus half square. Okay, now 1 minus 1 by 4 is how much? It is plus 3 by 4, but I will express that 3 by 4 as whole square. Okay, so this can be written as root 3 by 2, because root 3 square is 3, 2 square is 4, and we need 3 by 4. Okay, so we have expressed this quadratic expression as the sum of two perfect squares. So that was our rule, okay, according to type A. Okay, now let us rewrite this integral. So this integral can be written as integral dx by, instead of this I am writing this whole quantity. Okay, so instead of this I have written this one out here. Is that clear? Now we have already seen this kind of problem in earlier exercise, right? So in this case what do? I'll take this to be equals to some other variable. Okay, so let me call this to be my integral I. So let me do substitution out here. So let x plus half equals to t. So if I do this substitution, then from here I see that after differentiation I'll get dx equals to dt, right? Okay, so therefore my I can be rewritten as integral. Now instead of dx I am writing dt, okay, by this is my t square plus we have root 3 by 2 whole square. Okay, now this falls under the category integral dx by x square plus a square, which is how much? Which is 1 by a. And how much is a? A is root 3 by 2 tan inverse x by a. And how much is x? X is t out here, okay, by a. A is how much? Root 3 by 2. Okay, now let us put constant of integration, as we are done with the integral. Now let us substitute the value of t. And how much is t? T is equals to x plus half, right? So this can be simplified in this way. This 2 goes to the numerator, so we have 2 by root 3 tan inverse. So this is again 2 by root 3, right? Okay, and let me put this bracket out here. So this t can be written as x plus half, right? So with this we'll put constant of integration. So this will be my answer for this question. So pause the video to note down. Okay, so let's go to the next question. So in the beginning itself I'm calling this to be my integral I, right? Okay, so again this falls under your type A integrals. Okay, and here the quadratic expression given is under the square root sign. Okay, and whenever you have been given the coefficient of x square to be other than 1, okay, so for example the coefficient of x square here is -3, so that has to be taken outside as common, as you can see from the rule. Okay, so in the rule it is given that a is kept outside and you have expressed it in the sum or difference of two perfect squares, right? Okay, so let me write the quadratic expression given to us. So we have 1 plus 2x minus 3x square. So a is equals to how much? -3 here. So that a has to be kept outside. So -3 is kept outside. So we have x square here, right? So from here how much will be left? -2 by 3 x will be left. Okay, as you multiply these two you'll get 2x, right? So this and this gets multiplied to get 2x, and similarly I have -1 by 3 left. Okay, now I don't have to do anything with this -3. I just need to express whatever is inside as the sum or difference of two perfect squares. Okay, so let me quickly do this part. So here a is given to be x. Okay, so we have a square, minus is there, so it will be a minus b whole square. So a square minus 2ab plus b square. Okay, so a is x as it is. Okay, so 2a is x. Now I have to put b in such a way that when I simplify this I'll get this number. So obviously that number has to be 1 by 3, right? So that will get 2 into 1 by 3 is 2 by 3 into x, that is 2 by 3 x. Okay, so b is 1 by 3. Okay, so plus b square comes, so b is 1 by 3. Now this is extra, so that's why I'll remove this. Okay, and we have still -1 by 3 with us. Okay, so from here to here is my a minus b whole square. So let us write a minus b whole square out here. So we have a, that is x, minus b. B is 1 by 3 whole square. Okay, so this is -1 by 9 minus 1 by 3. Okay, now when you simplify this you will get -4 by 9. Okay, so you can simplify this by yourself. Yes. Okay, so we have -3 x minus 1 by 3 whole square minus, as I said, this will be 4 by 9, which can be written as 2 by 3 whole square, right? Okay. Okay, now we will multiply this full thing by negative. So whenever you get negative outside, so you will multiply after representing this as a sum or difference of 2 power x square. You can multiply only with negative sign, not with the number. So if I do that, then this will be equals to 3 will be kept outside. So this will become 2 by 3 whole square minus x minus 1 by 3 whole square. Yes. So you need to remember this thing. Now let us go back to our work. So we have integral this much, right? So we have integral dx. Okay, so square root sign is there. So let me write square root sign also. So square root sign is there. So we have this to be equals to how much? This is equals to 3 2 by 3 whole square minus x minus 1 by 3 whole square, right? Okay, so this root 3 is a constant, so that's why it can be kept outside integral sign. So we have okay, so this is left with us. Now the next part that we are going to do is we'll do the substitution here. Okay, so our substitution is going to be this one. Okay, so let me write this as let x minus 1 by 3 equals to t. So from here, as usual, we see that dx will be equals to dt, right? So our integral, that is I, becomes, so instead of dx I am writing dt. So we have 1 by root 3 outside. So we have dt by square root of 2 by 3 whole square minus this t, so this becomes t squared. Okay, now this is under the formula dx by square root of a square minus x square, right? And we know that this will be equals to how much? So this will be equals to 1 by root 3 is as it is. So this is my sine inverse x by a, right? So sine inverse x is t, right? So t by a is how much? 2 by 3. So let me put constant of integration. So we have 1 by root 3 sine inverse. So this becomes 3 by 2 into t. And how much is t? T is equals to x minus 1 by 3. Okay, so this will be our answer for this particular question. So pause the video to note down. Okay, let's have a look at this question. So this is my integral I. Okay, so here we clearly see that there has to be some substitution done out here. Okay, so the substitution that you are going to make out here is e to the power x equals to t. Okay, so if I do that, so let me write let e to the power x equals to t. That means you will get differentiation of e to the power x will be e to the power x dx, right? And here you will get dt. Okay, so let us rewrite this one. So therefore my I becomes e to the power x dx can be written as dt, right? Okay, so e to the power 2x can be written as e to the power x whole square. That is e to the power x whole square is t square, right? Minus 2 e to the power x is t, so 2t plus 4. Okay, now here we see that this is a quadratic expression, right? So we will write this as a sum or difference of two perfect square. Okay, so we have 3t squared minus 2t plus 4. Okay, so here a is equals to 3, so that has to be taken as common. Okay, so if I take out 3 outside, then I have t square minus 2 by 3 t plus 4 by 3. Now our next job is to express this as a sum or difference of two perfect squares, right? So let me write 3 as it is outside. So this is my a, so a square minus is there, so minus 2ab plus b square minus b square. Minus b square is extra. Okay, so at last we have 4 by 3. Okay, so let us see what is a is t. Okay, so t square. Now 2a is t. Now b I have to choose in such a way so that I'll get this number. Obviously the number is 1 by 3, right? So again this is my b, so that's why I need to put b square out here. Okay, so this is extra, so that's why I'll balance this by putting 1 by 3 whole square. Okay, so from here to here is how much? This a minus b whole square, right? Okay, so this is how much? This is minus 1 by 9. Yes, so simplify this, you'll get 11 by 9. Okay, so 11 by 9 can be written as square root of 11 by 3 whole square, right? So I hope you will be able to do this part by yourself. This is minus 1 by 9 plus 4 by 3. Okay, so here we don't have negative, so we will keep it as it is. Okay, so therefore this can be rewritten as integral of dt by, now this full thing can be written in this way, so this 3 can be kept outside. Okay, so I have 1 by 3, so we have t minus 1 by 3 whole square plus square root of 11 by 3 whole square. Okay, now again I'll do the substitution here, so let me write, let t minus 1 by 3 equals to u. So from here we see that dt will be equals to du, right? Okay, so therefore my integral I will become 1 by 3 integral dt is du by this whole thing is u, so u square plus root 11 by 3 whole square. Okay, now again this falls under the category dx by x square plus a square, which is how much? Which is 1 by a. So this is 1 by 3, so here we need to write 1 by a, and how much is a? A is root 11 by 3. Okay, so 1 by a tan inverse x by a, and how much is x? X is u out here, so u by a is root 11 by 3. We'll put constant of integration out here, so this 3 and 3 gets cancelled, so we have 1 by root over 11 tan inverse, so this is 3 by root 11, u is there, and how much is u? U is this much, right? So t minus 1 by 3 I have to write, but how much is t actually? T is e to the power x, so that's why I'll write e to the power x, that is t minus, instead of u, t minus 1 by 3. Okay, so we'll close this bracket with constant of integration. So this will be our answer. Pause the video to note down. Okay, let's see this particular question. So here as well we have to do some substitution. Okay, now we have to do substitution in such a way that sine 2x dx will be written as something like dt or du. Okay, so if I take the substitution to be t, then I will get dt instead of sine 2x dx. Okay, and that can be done, that kind of substitution can be done only if I write this integral I as this one, that is sine 2x dx divided by this sine to the power 4 can be written as sine square x whole square plus this cos to the power 4 can be written as 1 minus sine square x whole square. Yes or no? Because 1 minus sine square x is cos square x, so cos square x whole square is cos to the power 4x. Now the substitution that I am going to do here is sine square x equals to t. Okay, so let us write sine square x equals to t. Now let us differentiate. So differentiation of sine square will be 2 sine x, so this is for power, and for sine it will be cos x dx equals to dt. Okay, now how much is this? This is 2 sine x cos x sine 2x dx, and sine 2x dx is equals to how much? dt. Okay, so let us go back to our integral I. So therefore my I becomes, so sine 2x dx can be written as dt, so we have integral dt by, this is t, sine square is t, so this is t square plus this is 1 minus t whole square. Fine. Okay, so let us open the bracket. So t square is kept as it is. So this is 1 minus t whole square, which is a minus b whole square. So if I put a minus b whole square formula here, then I'll get 1 minus 2t plus t square. Okay. Now if I simplify this further, then this will be equals to integral dt by t square plus t square is 2t square minus 2t plus 1. Okay. Now our next job is to express this as sum or difference of two perfect squares. Okay, so let us quickly see how to write the quadratic expression as a sum or difference of two perfect squares. Okay, so we have 2t square minus 2t plus 1. Okay, so first what we are going to do is we'll take out a common, that is 2. So 2 is kept outside, so we have t square minus t plus half with us, right? Okay, so this work actually has to be done here, but since I don't have space, so that's why I'm showing it here. So this will be equal to 2. Now let us express this entire thing as a sum or difference of two perfect square. So this will be written as a square minus is there, so minus 2ab plus b square. So this plus b square is extra, so to balance it I'll put minus b square plus how much is there? Half is there. Okay, so a is as usual t, so 2a. Now b is chosen in such a way so that I'll get only t, so that b has to be exactly half, so b square, so half is square minus b square, that is half square. Okay, so from here to here is how much? This is a minus b whole square, right? Now minus half square is 1 by 4 and this is 1 by 2. So 1 by 2 minus 1 by 4 is how much? It is equals to exactly half, right? 1 by 2 minus 1 by 4 is 1 by 2. So that 1 by 2 can be written as 1 by root 2 whole square. Is that clear? Okay, so our integral, so this integral turns into, let us see what it turns into. So we have integral dt by, so this entire thing can be written in this way and this 2 can be kept outside. So we have t minus half square plus 1 by root 2 square with us. Okay, now we will do the substitution, next substitution, that is t minus half. So let t minus half equals to u. So from here I will get dt equals to du, right? So therefore my integral I changes to half integral dt is equals to du by, this is again u square plus 1 by root 2 square. Okay, now this again falls under the same category, that is integral dx by x square plus a square, which is 1 by a, so half is there, so 1 by a is how much? 1 by root 2 tan inverse x by a, that is u by a, that is 1 by root 2 with constant of integration. Now this root 2 goes up. Okay, so root 2 by 2 is how much? It is 1 by root 2. Okay, so we have tan inverse, so this goes up and becomes root 2u, right? So root 2u, but u is how much? U is t minus half, right? And how much is t actually? T is sine square x, so that's why I am writing instead of u sine square x minus half. Okay, so we have sine square x minus half with constant of integration. So this will be my answer for this particular question. Okay, let us go to the next question. So this falls under your type C. Now you might be wondering, why am I doing type C without going to type B? So the reason is very simple, because from type C will come down to type B. Okay, so we will directly go to type C. so that we will again see type B from type C itself. So this is my integral I. So from now onwards our integral is going to be a bit longer. So the rule says that we need to rationalize the numerator. Okay, so let us rationalize the numerator. So to rationalize the numerator, what I need to do here is I need to multiply both numerator and denominator by how much ever is my numerator. So I have in numerator, so square root of 2x plus 1 by square root of 3x plus 2, right? So this particular thing can be written this much. So to rationalize numerator, I will multiply it with the same number, that is the numerator itself. So in the denominator also we will put the same number. Okay, so this will be equals to how much? So this is 2x plus 1, right? So this into this is just 2x plus 1. So we have 2x plus 1 divided by, okay, so square root of 3x plus 2 into 2x plus 1. Okay, so we have 3x plus 2 into 2x plus 1 will be equal to square root of, okay, so as I said, this into this becomes exactly equals to 6x squared. So I hope you will be able to multiply. So 6x squared plus 7x plus 2. Okay, now if you see this particular one, this falls under category B. Okay, that is type B. Okay, so let us quickly see the solution for type B. Now type B says we have to express px plus q as, okay, so let me write, let px plus q, that is 2x plus 1 equals to a into derivative, that is d by dx of denominator. So that is 6x squared plus 7x plus 2. So we have 6x squared plus 7x plus 2. Fine. Plus b also we need to put here. Now our aim is to find the value of a and b. Okay, so let us see how to find a and b. So from here we see that 2x plus 1 will be equals to a into, so let us differentiate this. So differentiation of 6x squared will be 12x plus the differentiation of 7x will be just 7 plus b. Okay, so from here we get 2x plus 1. So from the left hand side we see that x is kept separately and the constant term is kept separately. The same thing we are going to do out here as well. So from here we see that this will be 12ax plus rest everything is constant. So that's why I'm putting them in a bracket. So it will be 7a plus b, right? Now if you compare both sides, so comparing both sides, the quotient of x here is 12a and the quotient of x here is 2. Okay, so comparing both sides, so we see that 12a will be equals to how much? 2, right? So 12a will be equals to 2 and let me write, and 7a plus b will be equals to how much? So the constant term will be equals to 1 here. Okay, so from here we see that from the first part we see that what is the value of a? The value of a turns out to be 1 by 6. Okay, so let me put the value of a here. So this becomes 7 into 1 by 6, that is 7 by 6 plus b equals to 1, that is b is equals to 1 minus 7 by 6, which is minus 1 by 6. Okay, so therefore our integral changes to, so this particular integral changes to, so again you have to rewrite this. I don't have space, so that's why I'm directly joining here. So let me join here. So this becomes, so 2x plus 1 can be written as, 2x plus 1 can be written as this much, right? Hope you are able to understand. So instead of 2x plus 1 I am writing this much. And what is a? A is 1 by 6. So we have 1 by 6 into 12x plus 7 plus b. And how much is b? B is minus 6. So that's why I am writing minus 1 by 6 by square root of 6x squared plus 7x plus 2. Okay, so this integral is longer here, dx. Okay, so let us separate this whole integral into two integrals. So the first integral that I'm going to do here is 1 by 6 will be kept outside. So here we have 12x plus 7 divided by square root of 6x squared plus 7x plus 2 dx. Minus is there, so minus 1 by 6 will be kept outside. So we have dx by square root of same thing, that is square root of 6x squared plus 7x plus 2. Now let me call this integral to be I1. Okay, so this is 1 by 6 I1 minus 1 by, okay, so again this is also 1 by 6, so 1 by 6 I2. Okay, so this full thing is I2 and this integral is I1 for me. So let us evaluate I1 and I2 separately. Now to evaluate I1 and I2, so let us begin. So we have I1 equals to integral of 12x plus 7 by square root of 6x squared plus 7x plus 2 dx. Okay, now here I'll make some substitution. The substitution that I'm going to make here is, let the denominator, that is 6x squared plus 7x plus 2 equals to t. Okay, so after differentiating, what will I get? So differentiation of 6x squared will be 12x plus differentiation of 7x will be the 7, and we'll have dx equals to how much? dt. So instead of this and this, I'm writing dt now. Okay, so this becomes, so therefore I1 turns into integral, so this into this is dt, so integral dt by square root of this whole thing is how much? t, so square root of t. So this is nothing but t to the power minus half dt, which is how much? So this is t to the power minus half plus 1 divided by minus half plus 1, which is equals to how much? 2 root 2, right? I'm sorry, 2 square root of t, right? Because this is t to the power half, so square root of t. And how much is square root of t? T is equals to this much, so this will be square root of 6x squared plus 7x plus 2. Now if you want to put constant of integration, that's fine, or else we are not yet done with this integral, right? So that's why we leave this I1 without any constant of integration. Okay, so you may pause the video to note down till here. Okay, now I2 is equals to this much. Okay, now this falls under your type A. So you see that we are coming down from type C to type B, and from type B again we are going to type A. Okay, so type A says that this quadratic expression has to be kept as a sum of difference of two perfect squares. Okay, so we have 6x squared plus 7x plus 2. So this 6 has to be kept as common. So we have x squared plus 7 by 6x plus 2 by 6, which is 1 by 3, right? Okay, so 6 is kept outside, so this has to be written as a squared plus 2ab plus b squared minus b squared plus this is how much? 1 by 3. All right, okay, so we have a squared plus 2a. Now b has to be chosen in such a way so that I'll get 7 by 6. So the number has to be exactly 7 by 12, right? Okay, so b is 7 by 12, so this will be 7 by 12, so this also becomes 7 by 12 here. Okay, so this will be equal to 6 into, so this is my a plus b whole square. So a plus b, b is 7 by 12 whole square, and here we have got minus 49. See, this can be written as minus 49 by 144 plus 1 by 3. So after simplifying that, you will get minus 1 by 144, which can be written as minus 1 by 12 whole square. Okay, so this can be rewritten as, so 1 dx by square root of, so this full thing is equals to this much, right? So we have root 6. So 1 by root 6, let us keep it outside. Okay, so we have this left, that is x plus 7 by 12 whole square minus 1 by 12 whole square. Okay, now let us do the substitution, that is let me write it here. So let x plus 7 by 12 equals to, now we have already used t in earlier case, so let me write this to be u. So this can be written as dx equals to du. So this becomes 1 by root 6 integral du by, this is u square minus 1 by 12 whole square. Okay, now this integral is of the type integral dx by square root of x square minus a square, which is equal to how much? Which is equals to 1 by root 6. So this will be equals to log x plus, okay, so what is x? So x is u here, right? So log of u. Now what is u? So u is exactly x plus 7 by 12, right? So log x plus, okay, so plus will be there, plus square root of x square minus a square, that is u square minus 1 by 12 square, that is u is this much, so x plus 7 by 12 whole square minus 1 by 12 whole square. Okay, so that's all is the integration. We will again not put any constant of integration, so we'll put constant of integration only in I, not in I1 and I2. Okay, now if you want to simplify this further, this can be simplified. Okay, so but for now let us leave it like this. Let us go to our I. So therefore I says that I is equals to 1 by 6 I1 minus 1 by 6 I2. Okay, so let us substitute the value I1, 1 by 6, and what is I1? So I1 was turned out to be 2 square root of 6x square plus 7x plus 2 minus 1 by 6. Now I2 turned out to be 1 by root 6 log of x plus 7 by 12 plus right. Now as I said earlier, we'll put constant of integration only with I, so that's why I'm putting a constant of integration out here. Okay, so if you want to simplify this can be simplified. For example, this and this gets cancelled, so this whole thing can be written as okay, so this will be our final answer for this particular question. So pause the video to note down. Okay, dear students, let's have a look at next question. So again, this falls under your type C. Okay, so as we are familiar with type C kind of problems, so let me directly write this to be equals to I. Okay, and we'll rationalize the numerator. So let me write this quantity as a plus x by square root of a minus x, and to rationalize the numerator we'll multiply it by the same number, right? Okay, so the numerator turns into how much? It will turn into a plus x by, so the denominator turns into a minus x into a plus x, that is a square minus x square dx. Okay, now according to the rule, this falls under your type B, right? And type B says that px plus q, that is the numerator, has to be taken as right. Okay, so a plus x will be equals to a into derivative of this quadratic expression plus b. Okay, so let us simplify this. So we have a plus x equals to a into derivative of this will be equals to minus 2x plus b. Okay, that is plus x equals to minus 2a x plus b. Okay, so comparing both sides, so comparing both sides, so we see that minus 2a is equals to a. That is, from here, what is capital A? So capital A is minus a by 2. Okay, and what is the value of b? Okay, I'm sorry, this is in the term containing x is present out here. So comparing both sides, this will not happen. So comparing both sides, minus 2a will be equals to the quotient of x here is 1. Okay, so minus 2a will be equals to how much? It will be equals to 1. So from here a will be equals to minus half. Okay, and the constant term here is b and the constant term here is a. So that's why capital B will be equals to small a here. Okay, so therefore this integral I can be rewritten as integral, so a plus x can be written as this much, right? So a is how much? A is minus half, so minus half into minus 2x plus b. B is how much? B is equals to a. Hope this thing is clear. Let me repeat once again. So a plus x is there, so instead of a plus x I am writing this quantity, and how much is a? A is minus half minus 2x plus b. B is how much? A. Okay, divided by whatever quantity is there. I'll write down the same one here. Okay, so this can be written as, so minus half will be kept outside, so we have minus 2x by square root of a square minus x square dx. Okay, so plus is there, plus integral. Okay, so this a is a constant, so it will be kept outside a, so we have dx by right. Okay, now here you have to make use of integration using substitution. Okay, now for example, now this falls under your direct formula. Okay, so let me directly write down the answer for this. For this, my substitution is going to be, let a square minus x square is equals to t. So from here you will get minus 2x dx will be equals to dt, right? So this can be rewritten as minus half, so minus 2x dx is how much? Dt. So integral dt by square root of this whole thing is equals to t, right? Okay, so plus a into, now what is the integral of this? So this will be equals to sine inverse x by a, right? We have not yet finished our integral part, so this can be, or this has been seen in the earlier problem. So the integral of this was equals to 2 root over t, right? So minus half is there, so into the integral of this is 2 square root of t, and how much is t actually? So t is equals to this much, so that is a square minus x square plus a sine inverse x by a. Now since we are done with the integral part, so we'll put a constant of integration. These two gets cancelled here, so that's why my answer will be minus square root of a square minus x square plus a sine inverse x by a with constant of integration. So pause the video to note down. Okay, now let us move on to the 7th question of the day. So let me call this to be I. Okay, so again within square root sign we see quadratic expression out here, right? Because we have x square, so that's why it has to be quadratic expression. Okay, and whenever we see quadratic expression only in the denominator, then this falls under your type A. Okay, and type A says that we have to express the quadratic expression in the as the sum or difference of two perfect squares. Okay, so we have 2ax minus x squared. Now what is a here? That is the coefficient of x squared. it is minus 1, right? So minus 1 has to be kept common. So let me write minus outside, so it becomes x square minus 2ax, right? So to express this as a sum or difference of two perfect square, I'll write a square minus 2ab plus b square minus b square. Now since we don't have any extra term, so that's why I'll close the bracket. So here a is x, so 2a is x, right? B, now I have to choose b such that you'll get this much, so obviously that number has to be a, right? So 2 into x into a is 2ax. Now this a is my b, right? So we have to put b square. Now this b square is extra, that's why I'll subtract b square from here. Okay, so from here to here is a minus b whole square, right? From here to here is this much, so we have ultimately minus a square. So as I said, if I get negative outside, that negative has to be multiplied. So after multiplication it becomes a square minus x minus a whole square. Is that clear? Okay, so that's why this integral turns into integral dx by, so this full quantity, so within square root, can be written as a square minus x minus a whole square. Okay, so the next substitution that I'm going to make here is x minus a. So let x minus a is equals to t. So from here dx will be equals to dt, right? So therefore my integral I turns into integral, so instead of dx I am writing dt by square root of a square minus this x minus a is t square, right? So again this is equals to how much? This is equals to sine inverse x by a, right, with constant of integration. Now let us resubstitute the value of t. So t is equals to x minus a. So that's why my answer for this particular question is sine inverse x minus a divided by a with constant of integration. So pause the video to note down. Now let's take this question. So this question falls under the fourth category, isn't it? So if this is my integral dx by ax plus b square root of cx plus d, as per the rule we need to take cx plus d, that is within square root sign, whatever we have to take that to be equals to z square, isn't it? So let me do that only. So I'm assuming, so let 1 minus x, that is cx plus d, is equal to z square. So basically as you are substituting x with z, let's see what will be the value of x, I'm sorry, dx. Okay, we need to substitute dx also. So let me call this to be integral I. So from here we see that minus dx is equals to, differentiate this, so this becomes 2z dz, right? So basically from here we see that dx turns out to be negative of 2z dz, right? Okay, so if that is so, then from here what is the value of x? The value of x turns out to be 1 minus z square. Okay, now let's go back to our integral I. So therefore your I will become integral, so dx is minus, so let me keep this minus outside, so we have 2z dz divided by 1 plus x. So we have 1 plus x is there. So what is x? X is 1 minus z square, isn't it? So this is my 1 plus x. So we have got square root of z square. Okay, so this is, okay, so you can take out 2 also outside. So this becomes dz, z is also there, I'm sorry, divided by, this is 2 minus z square, and square root of z square is z, isn't it? So z and z gets cancelled, so this is minus 2 integral dz by, this is 2 minus z square, right? So let's do one thing, let's multiply with this minus here. So if I multiply with minus, then this becomes z square minus 2. So this 2 can be written as root 2 square. Yes, so this is in the form integral dx divided by x square minus a square, isn't it? and the formula for this is 1 by, okay, so let me first write this 2. So this is 1 by 2a. So 1 by 2a. What is a? A is root 2. Okay. Please remember the formula. Okay, so let me first write down the formula for you. So the formula is integral dx by x square minus a square is 1 by 2a log of x minus a by x plus a. So this is the formula that I am using here. So this is my x, this is my a. So 1 by 2a log, okay, x minus a. So x is z here. So z minus a is root 2 by z plus root 2. Okay, so we'll put a constant of integration, but we are not yet done. So let me write your answer here. So this 2 and 2 gets cancelled. So we have 1 by root 2 log, now what is z? Z is square root of, okay, so from here let me write one more thing. So z is square root of 1 minus x, isn't it? Z square is 1 minus x. So that's why the value of z is square root of 1 minus x. So instead of z I am writing square root of 1 minus x minus root 2 by, okay, so z is again square root of 1 minus x plus we have got root 2 plus c. So this is my answer for this particular question. So let's take this question. So let me call this to be integral I. Now here what am I going to do is I will rationalize the integral. Okay, so if I rationalize, then okay, so we have x minus a, in the denominator we have x. So to rationalize I am going to multiply by x minus a in the both numerator and denominator. Alright, so we have, so this is, okay, so this becomes integral of x minus a divided by x integral of x minus a dx, right? Okay, now I am going to separate this integral here. Okay, so I don't have space, so let me write here. So this becomes integral x by x square root of x minus a dx. Okay, so first I have kept only this much. Now we have minus, okay, so this a is a constant, so can be kept outside integral sign. So we have dx by x square root of x minus a. Okay, so we got the two integral here. So let me call this integral to be I1, and we see that this and this also gets cancelled. And let me call this integral to be I2. So if this is so, then we get I1 minus a I2, isn't it? So let's calculate I1 and I2 separately. So we have I1 is equal to, so this is integral, I1 is integral dx by square root of x minus a. Now the evaluation of this I1 is very simple. You just need to substitute here. Okay, so you just have to write let x minus a equals to, make it z or t. Okay, so from here you get dx is equal to dt, right? Okay, so therefore your I1 will turn into integral, so dx can be written as dt by square root of, this is x minus a is t, that is, in other words, this is how much? This is integral of t to the power minus half dt, isn't it? So the formula says this is t to the power minus half plus 1 divided by minus half plus 1. So this is half, so this will turn into 2 square root of t. So your answer will be 2 square root of t is x minus a, right? So this is your I1. Now let's calculate what is I2. So I2 is this integral, that is integral dx by x minus square root of x minus a. Now this is again of type D, isn't it? So in type D, we have to take within square root whatever sign is or whatever quantity is there, that has to be taken as z square. So let x minus a is equal to z square. So from here we have x equals to a plus z square, and one more thing, that is the z is square root of x minus a. Remember that. Okay, now let's go back to I2. So therefore I2 becomes, so we have integral. Okay, so one more thing. So if this is so, then I have to write, or I have to differentiate also. So dx integral differentiation of a is 0. So this becomes 2z dz, right? So dx can be written as, so integral dx. So dx can be written as 2z dz divided by, so we have x. So instead of x I have to write a plus z square. Yes, so we have got square root of this. So this is actually how much? Square root of x minus a is z square. So that's why this can be written as z square. So again you see that square root of z square is z. So this and this gets cancelled. So we have 2 is kept outside. Yes, so this is integral dz dz by, we have a plus z square, isn't it? So can I write a plus z square as z square plus square root of a square? Can I do that? Yes. So if this is so, then your this integral dx by x square plus a square is 1 by a, that is a is root a, tan inverse of x by a, isn't it? So tan inverse x, instead of x we have got z, so it is tan inverse of z by a, and what is a here? A is root a. So that's why this turns into 2 by root a tan inverse of z. Now what is z? Z is square root, or you can combine this. See, z is square root of x minus a, divided by, you have got square root of a. So you can combine the both, and you can write it as x minus a by a. So this is the value of I2. So that's why ultimately your answer should be, okay, so I don't have a space here, I'll write my answer here only. Ultimately you will write, therefore I equals to, so I1. So what is I1? I1 is 2 root over x minus a into I2. I2 is this entire quantity, that is 2 by root a tan inverse of square root of x minus a by a with constant of integration. So this will be my final answer. Okay, so you may pause the video and note it down. Now this particular question is again falling under the same category, category D, right, or the fourth category. Now if you pay attention here, this within square root we don't have linear, that is cx plus d. We don't have kind of cx plus d here. Instead we have cx square plus dx plus e, isn't it? Within square root sign we have got quadratic expression. Okay, so in such case this is your ax plus b, this is square root of cx square plus dx plus e, right? So in that case the rule says that you have to put ax plus b. So here ax plus b is this one, so we have to take that quantity to be 1 by z square. So this is the rule. Okay, now again as you are substituting the value of x by z, so let's, I'm sorry, this is not z square, this is 1 by z. Okay, now let's differentiate. So if you differentiate, then you'll get dx equals to, differentiation of 1 by z square will be minus 1 by z square dz. Okay, now we founded the value of x plus 1, I'm sorry, dx, yes, using x plus 1 equals to 1 by z. Now let's see what will be x square plus 1. Okay, so x square plus 1 will be, so what is x in fact from here? So x is 1 by z minus 1, isn't it? So that's why this is 1 by z minus 1 square. See, why am I calculating x square plus 1? Because I have to find how much is this, right? So that's why I am calculating this. So we have this much. So let's quickly calculate this. So this is a minus b whole square, which says a square minus 2ab plus b square, and we have plus 1 also here. Okay, so this turns to be, so 1 by z square minus 2 by z plus 2, isn't it? If you want to take the LCM, let's take it. So z square is the LCM, so you'll get 1 minus, so this is 2z, and this is going to be just 2z square. Okay, so x square plus 1 turns out to be this much. Now let's go back to our integral. So therefore I will be, okay, so instead of dx I have to write, okay, so minus will be kept outside, so you have dz by z square instead of dx. What is x plus 1? X plus 1 is 1 by z, so that's why I'll keep 1 by z here. Okay, so this is in place of x plus 1. Now we have got square root of, okay, so x square plus 1 is 2z square plus, I'm sorry, minus 2z plus 1 divided by z square, isn't it? Remember, everything is within square root sign. So here you see that this z and 1z gets cancelled. So you have here minus integral dz by z is here. So we don't know what is the square root of this, that is 2z square minus 2z plus 1. We don't know what is the square root, but we know what is the square root of z square, and that is exactly z, isn't it? So again this z and z gets cancelled, so you have minus of integral dz by square root of 2z square minus 2z plus 1. Okay, now again you are familiar with this kind of integral. Now I am not going to complete this, I will just give you the answer for this. So your answer will turn to be 2 square root of sine inverse x plus constant of integration. See, this is the overall answer, okay, after substituting the value of z. So this will be your final answer for this particular question. So pause the video and note it down. Alright, so let me take the last question for the day. So the question says this one. Again, this falls under the same category. So this is my quadratic expression, yes, and this is my what should I say? So this is my ax plus d. I'm sorry, ax plus b. So in that case, again I need to take ax plus b equals to what? I need to take this to be 1 by z. So let 1 plus x equals to 1 by z. So clearly from here x turns out to be 1 by z minus 1. Okay, so differentiate this, so you get again dx is equals to 1 by z minus 1 by z squared dz, yes, and ultimately again we have to find what is the value of 1 plus x minus x squared. Let's find it. So 1 plus x, instead of x I am writing 1 by z minus 1 minus we have z x squared, that is 1 by z minus 1 square. Okay, so you clearly see that this gets cancelled, so we have 1 by z minus 1 by z square. Okay, so after simplifying this you will get minus 2 by z. Is it minus? No, it's going to be plus, minus 1. So this is what you get. Okay, so you see that this and this, they are like terms, so this becomes 3 by z minus 1 by z square minus 1. So again LCM is z square, so this becomes 3z minus, so this is my just z, I'm sorry, this is 1, right, minus here we will get z square. So I'm getting here 3. Okay, so let me keep it this much only for now. So therefore your I will change to, so therefore your I will change to, so integral dx, dx is negative of, okay, so negative is kept outside, so instead of dx I am writing dz by z square. So this is just dx. Now we need to write 1 plus x. So what is 1 plus x? 1 plus x is 1 by z. So this is 1 by z into, so we have got square root of this full thing. So we know that this is equal to square root of 3z minus 1 minus z square by square root of z square. So again, as usual, this and this gets cancelled. So square root of z square will be z. So that z and this z will also get cancelled. So you will get integral of dz by square root of 3z minus 1 minus z square. Now again, this is falling under the same category. We need to separate this as, or we need to write this as sum or difference of two perfect square. That's the rule. I'll just show that part and give you the final answer. You will try it by yourself. So we have 3z minus 1 minus z square. So first rule is keep the coefficient of z square, that is the highest power 1, positive. So we have got minus here, minus will be kept common. So this becomes z square minus 3z plus 1, okay, minus, okay, so you have to write this as a minus b whole square. Now see, this is my a, so a square minus 2az. Now I need to choose b in such a way that I'll get 3z, and that number will be 3 by 2 obviously, because when you solve this then only you'll get z square, I'm sorry, 3z. So if this is your b, then I have to write b square also, so that is 3 by 2 square, but this is my extra part, so I will balance this by putting minus of 3 by 2 whole square, but we have got plus 1 also, okay. So this is minus of, this is z minus 3 by 2 whole square. This is how much? This is minus 9 by 4. So 1 minus 9 by 4 is how much? Let's see. So this is 1/4. This is minus 5 by 4, isn't it? So when you simplify this part, it will turn to be minus, okay, so I have already written minus, so this is minus 5 by 9. Now multiply with this minus sign, so this will turn into root 5 by 3 whole square minus z minus 3 by 2 whole square. So this is the value. So that means your integral I can be written as negative of integral dz by square root of, so we have within square root this, that is this, which is root 5 by 3 whole square minus z minus 3 by 2 whole square. Yes? Okay, now you know how to do this. Your final answer will be e to the power sec inverse x plus constant of integration. So this is how you need to do. Thank you very much.